Today, we're going to simulate the process controller. So, the problem is the process controller is connected to a PLC with an volt with an output range of 4 to 20 milliamperes. What hex value range will be read by the PLC? So our minimum input is 4 milliampere. Our maximum output is 20 milliamperes. The maximum PLC value is 20 minus 4 is equal to 16 milliamperes, and our resolution is 6000. So, computing the value, 6000 times 12 divided by 16 is equal to 3600 in decimal, but if we will convert it to hex value, it will be E10. So these are the given parameters required for it. So we're going to use the SCL command for the flow rate and float level because the analog input is coming from the PLC, which will be received by the HMI. So for the flow rate, minimum output 0, minimum input 0. So this is actually 2, but we're going to change it into decimal value and scale it on the numerical display on the HMI. So this is the value that the HMI will read. And this is the maximum input coming from the PLC. So for the float level, it is actually the same concept, the same way on how we got the values, but it is a different parameter. So this is actually 100 because this is the maximum float level. But we're going to change it on the HMI, on the CX designer later. So for the SCL3, this will be, it is the input coming from the HMI and will be transferred to the PLC. We're going to place a value and then the data will be transferred to the PLC. So why did we get 0 on the offset? Computing the offset value, the resolution 6000 times 0 over 1000 plus b is equal to 0. So we got the offset of 0, but always remember that it is not always 0. So delta x 100. This is the maximum percent opening. So the servo valve can be fully opened or fully closed. So this 100 means that it is fully open. This is you can input a value of 0 to 100 to the HMI, and then the PLC will process the output. Delta Y 1770, Y max 1770, Y mean 0. This is the PLC ladder diagram. For the servo valve. For the flow rate and float level monitoring, servo valve monitoring, SCL3. Why did we use SCL3 in the servo valve monitoring and not SCL? Because again, we're going to input a value and control the valve. This rung means this is the solenoid valve 1, solenoid valve 2, solenoid valve 3, and the pump. So these are the output connected to the PLC. So now we're going to simulate. Simulation, start PLC-PT integrated simulation. Okay, so actually, this we cannot see the difference of the flow rate and float level in this simulation because this is not connected to the actual PLC and to the actual process controller, but we can simulate the servo valve and monitor it. Okay. So first, if we fully close the opening, this is the result. But if we close it half in into half, so it will result to 3,000. If we fully open it, we're going to input 100% opening. So it will result to the resolution of 6,000, which means that we've reached the maximum opening of the servo valve. So 50. Okay, this is the half of the resolution, half of the 6,000, which means that the simulation and the ladder diagram created is correct. So we can just try these buttons. Solenoid valve 1 activated, solenoid valve 2 activated, solenoid valve 3 activated, and the pump. Again, we cannot see the actual float level and flow rate because we are not connected to the actual process controller. Thank you.